So who I am? Who am I? I come from. My name is Marcelo. You can find me on Twitter everywhere as @MarceloSUD. I come from Brazil, this big country, which used to be very green. It's not so green anymore. And I code PHP for some maybe 10 years already. Yes, and I am living in Germany now, in Berlin, working at a company called CareShip. We are hiring if you are interested to maybe relocate to Berlin. Yes, and the idea is first I want to understand like who knows what CQRS is. Yeah, quite a lot of people. Who did already use CQRS in production? A little bit less. Who knows what event sourcing is? Cool. And who did already use event sourcing in production? Okay. Don't worry, it is usually like this. No, it's not so used, not so common. So I will not read everything there. Like you can maybe get the presentation later. So first I will maybe introduce what is not CQRS. Maybe the main point that I want to make sure everybody understands is that CQRS is not to have two different models for reading and writing, which is usually how we use CQRS. Like this, and I also added some stars there, as this is the definition that Greg Young gave 15, I don't know, years ago. And the idea is not to just to have to read and write models, but to separate the responsibilities. So actually, this is what CQRS means. Command and query responsibility segregation. The idea is the responsibility is split in two. Not on maybe the code can be, but the responsibility is a little bit a different topic instead of just code separation as well. And also, it means that you will end up with two objects instead of one now. So let's see a little bit of some code. Imagine this was a customer service before we apply CQRS. So we have two methods that are writing stuff, that are changing some state in the code, and two that are just retrieving some data, meaning they are not changing any state. This is what will happen after you apply CQRS. Mainly, you have two different objects doing this, one for the write part and the other for the read part. It doesn't mean, and that's why I added the stars before, it doesn't mean there are two different models. Because what do I mean by model? As you see, they both will deal with the same customer object, I would say. So they are dealing with one model. So this is the customer model, imagine. We just separated the code in two to make it easier to maintain and to bring some other benefits as well. Or if you are using maybe domain-driven design, it would look like something like this. You would have your aggregate as the right part of it, and you could have one or any amount of read models. Then you start applying the different idea of, then in this case you start having different models for that, which is usually how CQRS is applied, but it's not, by definition, it's not that. And so it brings some benefits. Like one that I would like to highlight is that you can have multiple read models. It makes it easier for you to implement also event sourcing. And you can scale if this is your business, if this is a business case for you, you can scale the read model independently from the write model, or the read part from the write part. Doesn't matter if they are using different models or not. So it's also a benefit. So some libraries on PHP to use CRQS. The one that I like most is this proof library. It's just way more complete than the others, but it is also very complex. Tactician is very simple to use, very easy to implement. But as it's simple, you have some limitations in terms of what you can do. But for most of the cases, Tactician will already solve the problem. And what about event sourcing? Later I'll show the code and explain how this happens in PHP. So what about event sourcing? Event sourcing is the idea that you never store data anymore. You only store events, and those events are your data. They compose your data. So through the time, like you have a time series of like, imagine everything that happens to a customer, for example, and this stream of events, this list of events, they compose the state of this any entity you have. And whenever you need to retrieve this state, instead of having a database saying like, what is the amount of like, how much do I have in my bank account, instead of going into the database and querying, select amount on a table, I will get all the events on my bank account and say, okay, credit, debit, sum them up. In the end, I'll have the total. This is mainly what event sourcing means, in a very simple manner, of course. This is the main architecture idea. I got it from a company called Confluent. They do a lot of consulting on this as well, and I'm not related to them. They have a lot of white papers as well. The idea is you have then your write. That's why also it relates a lot with CRQS, because you have it makes it way easier when you have a separate write part than the read part to use event sourcing. So you have everything that in your application are changing state in an event queue, and then they are saved in an event store, which can be anything that you want. It can be a MySQL DB, like a Postgres DB, Apache Kafka, as Confluent suggests, or like a CSV, a JSON, whatever. And then this is the application state will read from these events and apply those changes to the current state. And then whenever you need to read something, instead of going there in some place that you have the state, you read from the event list and you create your own state. I'll show that how that's done. So mainly, what are the benefits? I would like to highlight, I cannot just say all of them, but if you need, for example, different data views, different representations of your data, event sourcing will help a lot, because then it doesn't matter what is the data, you can generate a different version of this data, in a different representation of this data. Also, if you need audit log, event sourcing is a perfect match for that, because you have all the events there that happened ever. Then if you need to audit what happened, like to debug or whatever, you can see everything that happened. You can maybe replay them if this is a business case for you, if it is a use case. And also you can, at any point in time, find out what was the application state. So I want to see how was the amount that that this customer had on 2 weeks ago in his bank account. You can just play the events until that time, and you see exactly what was the state then. But there's a lot of drawbacks as well, because as it is like mainly a very uncommon approach to use, it has a lot of like a very steep learning curve. So everybody that comes to the company, if you need to train, like most likely you won't find someone, hey, we are doing, like, do you have experience with event sourcing? No, then I won't hire you. Like, you cannot just block someone because they don't know event sourcing, because there are not many people that work with that. So you need to train them, always and every time. Also, every time you have like a state, maybe a schema change on your events. Imagine before you have the events saying last name, like first name and last name, and now for some reason you want to use complete name or full name. All the events before then will still be there with first name, last name. And you need to somehow upgrade. This is called upcasting, which means every time you process this event, you will kind of wrap it and say, okay, first name, last name, concatenate becomes like full name, for example. These you need to handle, and it is complex. And also I would say, like, if it's not a business case, use case for you, like if you're not receiving or handling thousands of requests or events per minute, I would say it's not usually a suggestion to use event sourcing. So if you need just a CRUD application to read, update, create, delete, and whatever, don't use event sourcing. That will be an overkill for that. So maybe let's see some code before my time runs out. What I will show here is how to implement a very naive and basic implementation of event sourcing with some CQRS as well in the middle. So imagine I have this trait that gives the possibility of raise and erase events on any given object. So I'll say, okay, I want to have a possibility of raising those events, which in the end are just, it's just an array with some object inside, like an array with a list of objects, which I called domain event. If you are familiar with DDD, this is the same DDD domain event. And then I want to reconstitute from the events whenever I need to reconstitute the state. So very naively again, I just get all those events, replay them in my aggregate, my entity, my object, and then I have the current state of that aggregate or object. And this is how it happens in my aggregate root, or in my entity or my service. Imagine I received then a command from CRQS to change the locale of a customer. I will apply some business rules, say, okay, can I change this locale? Yes, then next step, I will raise an event that stating that this happened in the system. And one thing to notice is I didn't change the state here. So the locale was not changed yet. I raised the event, but the state is still not updated yet. I only update the state when I call this apply customer locale was changed, which is when I am reading from the event list. And why do we need to do that? Because if you need to reapply all events back from the beginning, you don't want any side effect in your code. Meaning, whenever, like, imagine there was an email being sent, like, welcome to Germany, now that you moved from France to Germany. And if I replay all the events, I'll send all the emails again. So no side effects can happen in the command part, in the write part. And that's why I need the separation, like, to how to apply that. So imagine I have a controller, like I received this command and sent this to a command bus, which is what handles the CQRS part, the command part. In the end, it's just imagine it as a service locale that will find a class to handle this request. So I sent this change the locale. Then this is the event, mainly, no, actually this is the command, meaning it's just a plain old PHP object with two variables, like two properties there, stating what this command represents. And the name needs to be very clear about what is the intention. So the name is usually imperative and saying like change the customer locale. That's a command. And I have, first let me show how this will, like maybe go for this one and then I explain the other. I have a command handler which will get this command and say, okay, what do I do with this change customer locale command? Okay, do this, like find this customer, then change the locale, then record the event that happened. Okay, then I'll call the repository. And the repository doesn't matter what it is. That's why I'm using the interface there, like implementing this customer repository interface. So my customer command handler doesn't understand who is doing that. It could be that I was using, running a MySQL query here or whatever. In this case, I am getting from the events. And this is where event source starts. I read everything from that customer and apply those events with this reconstitute from events method. And then I have the latest state of this object. And then I get all the events that happened and save somewhere. Yeah, it is very, very technical. But I'll explain the main benefit now, which is the different read models, which are called projections. So a projection is a representation, as I said, of the data in any different way you want. Depends on your business case. So imagine I have all those events happening in the system, and I have them in a log, which is this event store. Could be a JSON, could be a Kafka. Then I replay these events, like imagine all change customers locale events. And I want to see, for example, customers that moved, that are living in Germany. So I create a projector, which could be any name. I just create projector to make it a little bit simpler to understand. And whenever an event on the customer happens, I want to know. So I am listening to all events of this customer, and then I'll say, okay, when the customer was changed and the locale is German, then I'll add this to my projection. This projection could be an array, it could be a table, it could be like an XML file, whatever. Doesn't matter for me. I just want to add this customer. And whenever the customer locale changes to something that is different than German, then I will remove from my list as well. So I keep track of the data on my side. So imagine we have two different teams working with customers. One is the customer care team, and the other is customer service. And me, as the customer service team, I want to know when the customer moves to Germany. I don't need to go there and ask the other team, and ask, hey, can you create an API for me so that I can read whenever the customer changes and something like that, and they need to implement this in the database and whatever, create a table, create a view. So you don't need them anymore. In your side, you just say, okay, whenever this happens, I will save on a table on my side, and I don't care about the rest. This also helps a lot on ETL, on business, like BI as well. And this is an example of a projection, which is, in this case, very naive again. Just a table where I say, okay, customers in Germany, projection. And whenever I have to add, insert, whenever I have to delete, remove, I delete, and that's it. So I will always, in real time, have a table with all customers that are in Germany. Meaning whenever somebody, now I'm receiving 1,000 requests per second, I don't need to query the events anymore. I read them from my view. And as I am updating this in real time, of course, there are some delay, like milliseconds when we need to wait for the event to come. But in real time, I have a representation of the data that I want. You could have like 1,000 different representations depending on whatever you want to build. And this is the main benefit of using event sourcing. Because again, like if you have this use case of receiving a lot of requests and you need to read a lot of data every time, maybe some analytics tool that you have, this would be a very nice use case. Yes, some libraries for that. Event source is the simplest one, I think. Very easy to use, very didactic as well. It gives you a lot of flexibility, so also you need sometimes to implement some things that they don't implement. But they give you the responsibility on some things. Proof is a very opinionated library. It does it very well, but it needs to be in their way. Like if you want to do like differently, you either need to re-implement or don't use mainly. Yeah. Any questions? We have 8 minutes. Yes. Do I need to do the microphone there or not?
When you create a projection in the background, you say it's asynchronous. How you handle the connection to the front end, because you cannot make a request, change anything, and get the response directly with the changes, because you have to wait to the projection when it's updated. How you handle this with your front end?
Mm-hmm. Yeah, and then it starts to, this is a very common use case, yes, and a problem as well. Depending on the point of view, of course. So then we start to use a concept called eventual consistency, meaning you need to trust that at some point this data will be consistent. So your front end needs to be able to handle that at some point it will receive the latest data. For example, a use case for that is LinkedIn, as LinkedIn uses event sourcing. So if somebody likes a post on, like you posted something, somebody clicks on like, this will go into their event store, and then after some seconds you will receive the notification. It's not in real time. So the notification on your notification link, notification bar, only appears after it gets there onto the notification system. So the notification system is waiting for the thing to come. It's not actively asking for like, do you have anything or do you have the current state? It's just reacting to whatever happens. So that's how you need to implement the front ends. You need them to be reactive. They need to receive this data and know how to react to it, mainly.
So you said that ideally all the events would be persisted immutable, and ideally that would happen in a database that prevents change in the store. But how do you deal with a situation where you are legally bound to remove customer data, for example?
Yeah, GDPR. What did we do at a company I worked for? We also had this problem. We were running before GDPR with some this approach of immutable. It's not like in real, like it's immutable by the sense that nobody wants to touch it. You can go there and you can change if you want. It's not like I would say suggested to do that. In GDPR case, I would say save whatever data that is GDPR compliant connected somewhere else. And you connect this. Imagine, for example, I gave the customer locale example, but if you think like I want to save all customer data that are personal into this database, which is a relational database, and then I just say that it happened. So I say like, okay, it changed, the locale changed. I don't know what changed. I don't know what data is there. I just say it changed. If you want to know the data, you need to query the DB. And maybe you can have a timestamp like in the DB. It kind of makes way more complex, but you need to do. GDPR requires that. Yes. Any other questions? I have 4 minutes. No? Cool. Then, thank you so much.